for today's objectives. So for the last class, we talked about networking basics, a little bit about operating systems. Jackie covered that with you. Today, we're going to build on that stuff. Okay, we're going to talk about the Linux terminal. We're going to talk about some PowerShell. We're going to talk about some Bash. So we're going to get all kinds of technically and gremlin-like, which is very near and dear to my heart, my favorite parts of a lot of this stuff. So we're going to talk about the basic command line operations in Windows and in Linux. We're going to talk about just how basic networking concepts work. We're going to briefly touch on what a switch is, routers, firewalls, IP address. We're going to explain how Bash scripting works. We're going to talk about different tools that are available on Windows and Linux because there are different tool sets and different utilities based on operating systems. And we're going to set up and use the Linux command line interface, or CLI, to do all kinds of things, including make directories, make files, change file permissions, and all kinds of stuff like that. And that's going to lead into the stuff that you're going to do in lab. So I'm going to give you a brief demo, show you some basic things, and then your TAs are going to run through the expansive, full hands-on lesson during your lab for the next one. Okay, so again, don't panic. All right, so first, let's go back and we're going to talk about just the very basics of networking. So switches, routers, LANs, and WANs. For our purposes, because this is like an entire field of study in and of itself, and leads more to like the Net Plus certification as opposed to the Sec Plus, more IT related things than what we're going to be doing for the majority of this class. But I want you to know and understand the major difference between switches and routers. Okay, the really defining difference between switches and routers. Switches are used to direct inside a network. Routers are used to direct traffic in between disparate or different networks. Okay, at its core, those are their two functions. There's a lot more that goes into it and a lot of exceptions and things of that nature, but essentially for the purposes of where we're at, a switch is going to manage the traffic inside your network. It's even more, switches are even more tight than just local. It's more like internal to your network. Like a router doesn't have to be foreign. A router can be like neighbor to neighbor, like your house's traffic versus like your house and your neighbor's house, right? So the size of the network is also going to dictate how many switches, how many routers, things like that. We do have internal routers if the network's big enough. But again, for the most part, a switch is internal to the network. A router is external in terms of directing traffic. Added information, and the more definitive thing, in my opinion, switches route things based on MAC addressing, and routers route things based on IP addressing. Okay, so switches internal, MAC addressing, routers, network to network, intra-network, inter-network, and they route based on IP addresses. Okay, just the basics. Okay, nothing more than that. LANs and WANs. So the LAN is your local area network. So it's a small network like your home Wi-Fi. A business would have its own LAN. A WAN is going to be something much larger and covering a much larger geographic distance. Technically, WAN, which stands for Wide Area Network, technically the entire internet can be considered a WAN. Right? Geographically, if you interconnect every network on Earth, that's a wide area network, also known as the internet. Okay, so the size of WANs is going to depend on a variety of factors. LANs are generally going to be smaller. We have 1,000 other things that come into play with this that we're not going to talk about yet, including virtual LANs, wireless LANs, like all kinds of, VLANs, all kinds of other things that PANs, personal area networks. We're not going to talk about all of those today. Just a very, very basic general LAN for local area network, like your home network, a small business. And a WAN is a wide area network. It's much larger. It can include many different disparate networks connected to one another, and it can be spread across the planet. All right. Again, like I said, these are very, very brief intros to subjects that encompass an entire semester's worth of information. So please keep calm, introductory only, okay? IP addressing. So in general, we have two types of IP addressing. There are more, but we're only going to talk about these two. We have IPv4, which is the OG, and IPv6 that came about because the unthinkable happened and we ran out of IPv4. So IPv4 is smaller because the number of digits, I guess, the number of bits used to assign the name or the address was much fewer, which means you can only have so many combinations possible. At the time that IPv4 was really put into play, way, way back, like ARPANET days, no one ever conceived that it would ever have enough use for all these IP addresses. Like the idea that we would run out was inconceivable at that time. So, but once everything in the internet revolution happened and now your toaster needs its own IP address, clearly we ran out. Yeah, now your fridge needs an IP, right? So it's really, really, really different. And so they foresaw it coming. They knew that they were going to run out before they ran out. This was like in 96, 97, 98. So the late 1900s for you young people. And so they wanted to come up with this, and essentially they came up with IPv6, which is a great solution. It really was, but it didn't really get implemented because people were really busy with things like Y2K. So it got put on the back burner in terms of implementation, because it was also going to be really, really difficult to implement. Long story short, as a temporary fix, for IPv4 addresses, they ended up doing NAT. See, some people know. And what NAT did is it was like the Band-Aid for the IPv4 in terms of, well, what we'll do is we'll do external IP addresses until you get into a network. And then within that, you'll do private IP address spacing, and we'll let the networks handle it all. So the only public facing IP address is one. So even though you have 68 IP address necessary devices in your home, everything that comes into your home only uses one external IP address. And this Band-Aid was so good that a lot of organizations and a lot of things out there just decided, nah, I don't want to change over. Why? It's working just fine. So this is why we have IPv6 running rampant and IPv4. So they're both completely out there now, okay? Now, when we talk about subnetting is what you have to do using IPv4. There is no need to subnet an IPv6 because subnetting is built into the address. I'm not going to talk about that in any kind of detail. Just understand subnetting is when we had like this big chunk of addresses in IPv4. And because I had like 60,000, but I don't need 60,000 on my network, I had to have a way to section off the parts and pieces so I could lease them and rent them to other people. Look, if you're a single person, you have a Costco membership, and you want to go buy a really nice pumpkin pie because it's $5 and delicious, you're not going to eat that whole pie before it goes bad. So you're going to go home and you're going to cut that pie into pieces. And then you might give it to your neighbor, you might sell it on the street corner, whatever you might do with the rest, because technically that whole pie belongs to you. That's all subnetting is. Okay. Subnetting is taking your ownership of a large, large network you cannot possibly use and sectioning it off so you have your piece, the portion that you need and that you want to use, and that you can block off other sections. Now, if I give a giant wedge of pie to my neighbor, if they decide to divide that up between everyone in their house, they can do that too, right? So they can cut their smaller piece into an even smaller pieces. This is subnetting. Okay. All right. So this is my summation of IPv4 and 6. Again, just really brief overview. Okay, we're not getting into super detail. So what's the job of a firewall? Okay, the firewall is the moat, medieval castle that you have around your internet, so your network. your LAN. So my house, it's like having a little moat around my internet house. Okay. And that's the firewall. It's to prevent entry from things that I don't want to come in and only allow in the things that I do want in and out. Okay. That's what the firewall is supposed to do for you. Well, then we have configuring rules. Well, this is where it gets interesting. So firewalls have rules. Okay. Because different networks are going to have different requirements. Just like I have a network at my house, my local bank also has its own network. Do we think the firewalls at my house are going to have the same rules as the firewalls at the bank? No, the firewalls at my house aren't even going to be the same as my neighbor's house because my neighbor has teenagers. I'd have much more specific rules if I had teenagers in my house. So what the rules are for your firewall are going to be directly dependent on what you need to limit or give access to. They're also going to be directly, related to what you choose to do. Because even if you need the rules, I can't make you lock your doors. Some people, even though they need it, they won't do it. Somebody, something, some entity has to implement firewall rules. Now, for those of us that are normal people and we don't, jury rig all of our rules ourselves, Windows by default has a certain set of rules established for its firewalls. If you employ antivirus like Norton or McAfee or something like that, you have some presets, things along those lines. So that's your configuring rules. It's like the instructions you give your firewall. And then we have application insecurity. So it's not just the internet and it's not just what you're allowing in and out, but applications are very sophisticated nowadays. And so what applications that you may have installed on your computer are allowed to reach out to the internet and bring in and take out, that's also part of it. All right, so some networking tools that exist in Linux. Again, the tools are going to be dependent on the operating system. Just like, do we have any computer gamers out there? How about just regular gamers? Drop an emoji in the chat if you have an Xbox. Okay, drop an emoji in the chat if you have an Xbox. I see some ews. So for those of you that don't have an Xbox, I bet you have a PS5, right? Oh, then I see some PCs. Let me ask you guys a question. If I go to GameStop and I buy, I don't know, what's a fancy game out there now? Call of Duty, whatever number we're on for the Xbox, okay? Can I take that game and play it on my PlayStation? Can I take my Xbox game, play it on Pay? Okay. How about if I go to Steam Games and I download the new Batman game on my computer? Can I take that and play it on my Xbox? No, it works the same with all applications, guys. The tools that I have that I can use on a Linux operating system are not going to be the same as the tools that I can use on a Windows operating system. Make sense? So for the networking tools available in Linux, now some of them do have overlap. Okay, some of them do have overlap, just like I can buy Call of Duty for Xbox or PS5, right? The coding is going to be different though, because it has to be built for the right operating system. But some tools overlap, some tools are not. For Linux specifically, we have something called TCP dump. Okay. TCP dump is awesome because it shows you everything happening in the traffic on your network. The problem is it's dump for a reason. It dumps all the data into records for you. That's a lot of data. Okay. It's a lot. And it can take some time, especially if you have a large network, and how much you're asking it for. Netstat is another one. This one's a little bit more selective in the data that it gives you. And it gives you a dashboard that shows all the current ongoing activity. So what's happening now? All right. Not like stuff that happened, not stuff that's over, not stuff that's closed. It's like, what is currently the snapshot of activity on my network now? We have Netcat. So Netcat is if I want my computer, you have to be on the same network. So if I want my computer to look into your computer on one network, I can use Netcat for Linux operating systems, real time. Then we have DIG, which is Domain Information Groper. This is like getting information specific to website addresses. All right. So it's like supposed to go in and dig exactly as it says for websites. Netcat is a reverse shell's best friend. More like Netcat's the peanut butter to the jelly of reverse shell, but I'll give you that one. All right. So that understand that those few tools have like massive amounts of data that go with them. We're not going to cover that right now. So now we're going to hop to the next intro topic, and that's going to be the OSI model. Okay. So the OSI model stands for Open Systems Interconnection Model. So this is like, it's not a real physical thing. Okay. It's a conceptual idea. Okay. Basically, it's a conceptual idea so we can understand how network interactions operate and who's responsible for what. Who remembers their high school government class and being instructed on the separation of powers? So we have the executive branch, the legislative branch, and the judicial branch, right? Took me a second. Are they like physically completely separate? Like they don't interact anywhere? We don't have judges going into, but it's a conceptual ideas, right? It's based on the organization of things. The OSI model is the same. It's the organization of who's in charge of what. Okay. So, and it doesn't matter, Mac, Windows, whatever operating system, irrelevant. The OSI layers are supposed to tell you how things are organized in terms of what part of the computational system is responsible for what types of programming and activity. And this is going to make a lot more sense in a second. And you can read this, but what you need to know about the OSI model is it is a 7-layer structure that incorporates many, many, many different kinds of protocols. Protocols are nothing more than a series of instructions or rules that we all agree to abide by. Okay. Everybody agrees to abide by a certain set of rules. That's a protocol. Here's the OSI layers, and they always go from top to bottom. So from 7 all the way down to 1. And then the lower you get, the closer to the ones and zeros you get, the actual ones and zeros that all computation is based on. So level 7, this is called the application layer. And there are like 50 different acronyms. You can look up the OSI model. There's like 5,000 YouTube videos that tell you all about the OSI model and the 7 layers. Feel free to look into those. I'm just going to give you a very, very brief rundown. So layer 7 is the application level. This is considered a high level, including APIs and many other things that are like super, super high. Okay, when we say high level in computer science, it means the higher the level, the further away from the computer you are. Okay. Low level means you're closer to the computer. That's why high level programming languages like Python are easier for humans to understand, and lower level computer languages like machine code are easier for the computer to understand. Does everyone understand? High level to low level, right? So the function at the application layer, this means you're interfacing directly with applications like emails, file transfers, and web browsing. That's what's happening at the application layer. So here are some examples, what that would look like. Then we have the presentation layer. Presentation layer's job is to translate the information that you get from a network or an application into a format and application formats. It's also responsible for data encryption and decryption. So this kind of stuff would be like your docx type of file, right? Well, what reads PDF, right? PDF file goes to what application? HTML, making sure you're getting like the correct data in your browser, right? all of that stuff, AVI, is happening at the presentation layer. At the session layer, this is essentially what's being put in charge in managing communication sessions. For example, I will bet every last dollar in my bank account that every single person, there's like 800 of you, has more than one internet application open right now, or at least more than one tab. I'd be willing to bet every last dollar in my bank account that you have multiple. Okay, but did you ever think your computer has one IP address, right? Even internally. How are your applications knowing that this stream of ones and zeros goes to this tab, and this stream of ones and zeros goes to the Zoom call, and this stream of ones and zeros goes to the Amazon shopping that I know some of you are doing, or the TikTok browsing, or whatever the case may be, right? That's the session layer's job. That's not magic. There's a whole OSI layer in charge of separating that data, okay? And that's at the session layer. The transport layer, and these are some of the protocols that it deals with. At the transport layer, this is where we have a reliable transmission of data segments. If you notice, 5, 6, and 7 all happen at your computer. We haven't left, okay? Either the data has arrived and you're processing it and giving it to me, or I'm packaging the data like an email and getting ready to send it. 5, 6, and 7 happen on your machine in some form or fashion, okay? Whether packaging up to send or translating once received. Once we get to the transport layer, things start to change, okay? Here we have, notice something called a segment or a datagram, because here we have a protocol data unit. All this means is if I'm going to send an entire email, I'm not going to send it all in one packet. It's got to get chopped up first so it can be sent out in packets, right? On the internet. The thing that's responsible to make sure that the transport of these things occurs correctly and that things are chopped up appropriately is the transport layer, okay? The protocol data unit, the name of the chunks of data at this point, it's going to be a segment, also known as a datagram, okay? So once I chop up that email into little bitty pieces, getting it ready to package and send out into the interwebs, it's now called a datagram. But it's really, the datagram's name at this point is a segment, okay? Everyone with me? The protocols here are like TCP and UDP. I need to know if it's guaranteed transmission or not. Now, the next section, the layer 3 of the OSI, is called the network layer. Here is where IP, ARP, IPsec, these other protocols come into place. Now I take my segment and I encapsulate it. And encapsulation means I'm wrapping it in a package. So I take my little chunk of data and I put it in a box and I wrap it up. The box that I'm wrapping it up in has my IP address on the outside. Okay, so the to, the from IP, all of that. Now that I've encapsulated it and wrapped it up into the IP address, it's now called a packet. And these are the things that fly all over the internet. That's why we say packets everywhere, packets in, packets out, okay? Now, that's the network layer. Layer 2 is the data link layer. When I hand my packet off to the data link layer, it gets encapsulated again. And that encapsulation is going to be a MAC address. The protocols at this level are Ethernet, 802.11, which is wireless, any kind of tokenization that I'm doing, all of that happens here, okay? When you get the MAC addressing, so now I'm going to take the box that I had that was a packet and I'm going to put it in another box and I'm going to wrap it up. And my to and from address are going to be MAC addresses at this point, okay? I'm like, cool, it's all packaged up. Now I'm going to send it out. Once you do that, you go to the physical layer. And this is where you go to the actual wires where the zeros and ones, beep, 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 go out either in electrical form or in LED pulses of light. We good? Again, 1,001 YouTube videos on both this and encapsulation, how packets travel across the internet. Feel free to look into them. All right, so something to drink after that. So the OSI model in cybersecurity, why do I care? I mean, we're not programmers here. We're not learning how to do crazy things. You need it because every single one of those protocols, and at each of those layers, you can find vulnerabilities, which means like exceptions to a protocol or using a protocol in a way that it wasn't intended in order to gain access to information you're not supposed to have. Okay, so we have to understand the 7 layers of the OSI model so we can understand how some vulnerabilities and how some attacks work. All right. So OSI model is necessary also because all computers work this way. The fact that you're seeing me on Zoom, the fact that we're together on Slack, all of this is possible because all computers and all applications are essentially constructed with the same principles of these 7 layers of the OSI model and all the protocols that go with them. The only reason things like this work is because everyone agrees that these are the standards and we're going to build to those standards, right? So that's how that works. All right. So for this, please don't freak out. Please don't freak out. There's just really no way to get some of these answers correctly. You can always Google them. Okay. You can always Google them. What would be considered higher level, 7 or 1? The highest level is considered the application layer because it's the topmost. It's not really high or low, it's top and bottom. I hope that answered your question. So man in the middle attack, MITM, by sniffing the network. If I'm sniffing the network, what layer do you think I'd be at to receive and read all messages passing through the network? Which one? Data link? You guys think layer 2? 2 for application? Wow, we got a lot. I see a lot of, honestly, I see the most data link. I'm going to go ahead and put 2 and we'll see. It is in fact the data link layer. Here's the thing. Which I put 2 and it wanted data link. 2 is the data link layer, so it's correct. Here's the thing. Man in the middle, by sniffing the network at this layer to read messages passing through the network. If I'm going to be man in the middle and I'm looking at everything passing through the network, by definition, I have to be on the network. Does everyone understand? If I'm on the network, then we're at the MAC address, then we're at layer 2, which is the data link layer. Please don't freak out if none of this makes sense to you. That is completely okay. All right, so an attacker copies a user's session ID and impersonates them to get information from a website. This attack occurs at the what layer? Session layer. So we're going with 5. 5, 4, 3, 2, 1. It is in fact the session layer. So now an attacker conducts an SQL injection attack at what layer? To bypass restrictions and request unauthorized information through a web app. I'm seeing a lot of application. Yep, it's at the application layer. How about a denial of service attack? Denial of service attack. At the blank layer sends many requests to the same port. Port. Network? I'm seeing a lot of network. All right, we'll put network. Very good. Actually, I think I did put, yeah. So it's at the network layer. Again, please don't freak out if you don't know these. It's completely fine. A shimp's anchor cutting the underwater transatlantic network cable creates trouble at the what layer? Yeah, this is the physical layer. Like anytime you're physically preventing the 1s and 0s from going, right? Okay. So we're moving on. That was the easy part of the day. Now we're going to get into the fun technical stuff. Okay. Well, but so you need to know the OSI layers. I gave you the introduction. You're going to need to read a lot more about them, right? So it's fine. I'm only here to introduce you to the concepts so that you can conceptually get them. The studying and the memorization, that's going to be a little bit more on you guys, okay? All that section that we just covered too, I would go back and I would add to my flashcards or my definitions in my notes, because a lot of that information from the OSI model to the different tools that you'll find on Linux in much more detail, we will cover a lot of this material over again as well in lessons that we go more in depth, okay? But anything that you had up until now, definitely hit up. And it's okay if it doesn't make any sense the first go round, right? I promise. Okay, so now we're going to talk about the terminal. In Linux, okay, in Linux, the terminal, I want you to think of it like this. We are spoiled in that we have GUIs. Does anyone know what a GUI is? What does GUI stand for? And what is a GUI? A GUI is a graphic user interface, okay, which was at its time revolutionary, because instead of having to talk directly to the computer, you let me have a mouse and I could click on things for things to open for me. So it was very pictographic. Okay, it was very easy. I want you to look at it like this. Say you go to a very authentic Chinese restaurant. If all of the menu items were only written in Chinese with no pictures and no English descriptions, how would we all be doing with ordering? If the cashier also did not speak anything but Chinese, you'd have to learn enough Chinese to be able to order, right? Okay, so let's say the Chinese restaurant was like, man, these people are not going to learn Chinese enough for me to do good business. So instead, they print the menu with the pictures of all the dishes on it. You don't have to learn how to say or read anything now. You just point to the picture. That's essentially what Windows did for us. That's what our graphic user interface is. I don't have to tell the computer how to open my email. I just click, click, and I'm done. Okay. Now, all of that to say, at the terminal, before we had GUIs, you had to know enough of the computer's language to give it instructions in actual words that it could understand. And that's what goes on the command line interface. Okay. And that's all these are. Now, understand, Linux has a slightly different language than Windows. So this would be like I went to my Chinese restaurant and then I went to my Mexican restaurant. They don't speak the same language. So even without the pictures, I got to learn 2 whole different languages for that. Okay. Now they're a little bit more similar than that, but that's essentially how the command line interface is. You're talking directly to the computer. Okay. So this is what it's going to look like in your terminal, right? And this is a Linux terminal, you can tell, just because of its format and the fact that it's ending with a cash sign, or if it ended with a tilde. So that's how you know. You get direct interaction with your Linux system. Now, there is also a command structure for how you talk to the computer. Okay. For Linux, the command structure is you have the name of the command, then you have options, sometimes if you want to use any of the options, and after the options, there might be arguments. This sounds very complicated and it's not. It's like if I tell you, if we're speaking in English, right? The order of an English sentence is subject, verb, object. I am teaching. There's no object in that sentence though. I just have subject, verb, right? I am teaching. Subject, verb, object. I am teaching you. So I can have an object, but I don't have to. It's the same thing with the command line structure. I'm going to start with a command. Then if I want to include options, and then if I need to include arguments. Okay, this is how it works. This is going to make a lot more sense when we actually get into the commands. This is also really important because notice I said in English, it's subject, verb, object. Not every language is going to be in that order. I also speak Farsi. In Farsi, we have subject, object, verb. Verb comes at the end. The reason I give you that example is because Windows is not going to take commands in the same order. And when we start scripting in Bash or in any other scripting language, the language also changes. Okay? All right. So that's the command structure. You have the command name followed by options, which are optional. And then sometimes you can add arguments after that. This is an example that's not going to make any sense to you until we start doing it, so I'm going to skip it. When you have executing a command, so I type my command, my options, and my arguments, then I want to execute, I hit the enter button. That's the execution. Okay. You can do so many things in the terminal. There's really very little limit other than how much you know what to do. The limit is only going to be on your knowledge in terms of what you can get done in the terminal. The other benefit of the terminal is you can automate things and you can use scripting. In Windows, generally, you're going to be scripting using PowerShell or Python, depending. You can also use Python for Linux, but for basic scripting, you're going to use Bash. Don't freak out. We're going to cover all of this in detail in a little bit. Okay. Yes, you are all human language APIs. I like the analogy. I really do. So also we use primarily though for a lot of this, even if you're not going to do any real scripting, for any kind of troubleshooting, checking your network, looking at ports you may have open, any kind of like system management is going to be done at the command line interface. So why should you bother learning the terminal? Well, first of all, the terminal is very powerful. There are things that you can do in the terminal that's like really, really, really hard, complicated, and time consuming to do using the GUI. So it is a lot faster. And there's a reason for this. 35 years ago, not everyone had a computer at their home. And those that did, the learning curve was steep because you had to learn how to use the computer. So you had to be knowledgeable and educated. It wasn't exactly a user-friendly device. Okay. The first computer I had in our house, my dad handed me this massive, like telephone book sized instruction manual that showed us how to use DOS. And he said, figure this out. I need you to work the computer. Yeah, DOS. So I had to talk to the computer in MS-DOS. This is before the clicky GUI situation. Well, the user had to learn all those things, right? Once the system became user friendly and you didn't have to learn as much, now the system comes with click, click, bang, bang. Guess what happens to someone that doesn't really know how to use the device? More and more, the operating system had to take functions away from the GUI user so that they weren't breaking the computer. So it's deliberately buried, like trying to change or update the drivers on your Windows system or preventing an application from using certain things and giving that power to another application, manually doing that just using the GUI is a nightmare. And you want to do all of those things in the command line because it's so much simpler. All right. Just FYI. Yeah. Like it's harder and harder to do things in like the Windows. Like if you go to system and you're trying to change options and do certain things, they make it really, really hard. I get stuck. Sometimes I have to like go to Google to figure out how to operate. I'm not gonna lie to you guys. I once wrote a Python script to deactivate a driver because I got so mad at Windows because I couldn't find where it was and I couldn't get access to the stupid thing. So I kind of wrote a workaround and just had Python go do it for me. Anyway, so why the terminal? All of those things, scripting and automation, control, efficiency. It's also absolutely essential for any professional. Anybody that's going to get into cybersecurity needs to know at least the very basics. The very basic. Now, you don't have to know a lot, right? But you have to know at least enough to get by and identify what's happening. Okay, just so minimal, especially if you want to be a suit, but you still have to know the basics. The problem with stopping, actually, you don't have to write a script from stopping Internet Explorer from booting up. I've completely disabled it on my computer. I also turned off Edge, but we'll talk about that in another time. So you should consider using Linux when you need to automate repetitive tasks. Technically, I think they want a true here. Mona personally is going to disagree, because if I want to automate a repetitive task, I'm going to use Python. It is by far the better automation tool. However, since we may not necessarily want to learn a whole new programming languages, this is true, right? Because you need Linux just to navigate. So scripting, yes, the basics, absolutely. All right, moving on. So we're going to get into some commands here. All right, everybody with me? Everybody with me? So I'm going to introduce you to some of the basics. Now we have a whole bunch of instructions here. The only thing I want you to note, you can actually hit that clipboard and it will copy it. So you don't have to fat finger. You can just Control V if you want to. Okay. So that's just something you should know. Look to the right and we're going to discuss briefly what it's going to ask us to do. First, it wants us to display the contents of the directory we're in, changing a directory, making a directory, copying files from one directory, moving files, removing files, and creating empty files. Okay, so that's basically all we're going to learn to do here. We're going to do it in a slightly different order, because if you do it in this order, you're going to get errors because the file doesn't exist until you create it, and they don't create the file until the very end. So we're going to do it in a different order. First of all, and this is a basic command you should all learn, is ls. Okay, ls basically says, yeah, ls pipe grep. Some of you are plentiful in the bash already. So ls is list. Basically says where I am now, wherever it is, show me everything inside the directory that I'm in now. It is the equivalent. Everyone knows how File Explorer works, right? On our Windows, we all have this thing. So if I go to my desktop, it's going to show me every file and every folder on my desktop, right? Yes, that's all this is, only in the non-pictographic form. I am currently in Workspace. Okay, I am in Workspace. So just like I was in my desktop in File Explorer. So in Workspace, there is 1, 2, 3, 4 JPEGs. See how this is blue and that it doesn't have a dot extension? This is another directory. So I have a directory named project, some more JPEGs, some GIFs, and that's everything that's in this. PWD. Does anyone know what that stands for? It's print working directory. So just like here, okay, let me go back here. See here where it tells me where I'm at? If I go, say here, and I click, this says C users, user desktop pers 3650. That's the directory. It's a full path directory, okay? In Linux, that's print working directory. That means tell me where I am. Print working directory is you telling Linux, hey, tell me where I am currently. And it's going to tell you you're at home, Codio workspace. Does everyone see that? I would definitely write these commands down, and I would definitely invest some time memorizing them. These are it's like some of the stuff I give you is random. This is like learning addition before we get to the multiplication, division, and algebra. You need this. So yes. No. Print working directory is not ls. ls is tell me everything in the directory that I'm in. Print working directory is tell me the name of the directory. So this is your current location, and this is all the stuff that's located in that directory with you. Okay, that's how that works. So that's the list. Then we have, okay, that's fine. I'm in this directory, but I don't want to be in this directory. I want to be inside the project directory because I want to get a list of everything in that directory. CD is a command that works both in Linux and in Windows. However, they work with different syntax. I can't CD the same way. I have to CD with backslashes and other things in Windows. All of the ones that I'm giving you currently, now you don't have to memorize them today, but you're going to be practicing with them and you really do need to know them. The CD with the double dots goes up. Okay, I'm not trying to go up. I'm trying to go down because I want to go to project. So I'm going to CD and I'm just going to type P. The tab button is your friend in Linux because I don't want to risk fat fingering anything. So I'm going to start with P and I'm going to tab. And why did that not work for me? Did it work? There we go. There we go. So I'm going to go to the directory project. How do I know it worked? Do you see that the cache was after workspace here? Now I've got the subdirectory of project and the cache is after that. So I'm currently in, yes, everything in Linux is case sensitive and space sensitive. So projects with a capital P would give you, no, CD is change directory. CD is telling me to change my directory. I want to change my directory from where I was to the project. dir works in Windows. There is no dir in Linux. So is this what? No, this is not what Mr. Robot used to. Well, not all. You have, this is like the prerequisite, right? Of course. All right. So now that I'm in project, if I want to see everything that's in this directory, what would I use? Yeah. So in the directory projects, there are two other directories called backup and tests. Okay. If I wanted to, I could go to either one of those and see what's in them. Okay. Now what happens if I want to go back? I'm too deep now. CD and two dots takes me back up one. CD and two dots takes me, oh, I didn't put a space. CD space, two dots, and I go back to workspace. This is where I started. Everyone see that? So CD space, two dots means go up one. Okay. The terminal should have opened when you got to this particular scene. If you need, you can, tools. There we go. Under the tools tab, you can do terminal and it should give you the option to open a new terminal. All right, so far so good. Now we're going to learn how to make a new directory and to make files, okay? So to make a file, actually, let's start from here. Say I want to make a file, okay? The command for that is touch. I'm going to type touch and I'm going to name the file new file. .text. You have to add the .text. You could just also copy this and paste it here if you wanted. Now, that's it. If I want to see if it works, I'm going to type ls and look and see, whereas the directory before just had GIFs and JPEGs and then a subdirectory of project. Now I have something else called new file.text. So it made a file for me. It's a text file. Okay. It's empty. There's nothing in it, but the file still exists. Okay. Now that's how you create a file. Instead of, before I remove the file, I want to learn how to move it. So for the move command, it's just MV, but then I have to specify new file dot text. I know this says file dot text, but if I just did file dot text, it's not going to let me. And the reason it's not going to let me, do you see file dot text anywhere here? There is no file dot text. Because there is no file dot text, I got an error saying missing destination file operand. Oh no, this one it gave me the mistake because I didn't tell it where to go. Okay, fine. Go to project. All right, so I got a different error message. The first time for the move file, you have to have a destination. And because I didn't have a destination, the error that it gave me, it didn't care that it couldn't find the file.txt. It didn't even have a destination to begin with. So that's the error that I got. The second time, because I gave it a destination, it got, okay, great. I've got the destination. Then it went to go look for the file and it's like, hang on, you can give me the file. So that gave me a different error. Errors are your friends. Don't freak out about them. They actually give you a lot of information. So now, let's move new file, because that's the name of my actual file. And we're going to put it in the projects folder. Does that have the TS? Yes. Okay. Permission denied. Okay. See if this works. Yep. So we're going to talk about permissions in about 15 minutes. Don't worry about that. So every file on your computer is going to have, especially in Linux, every file, every directory, it's going to have permissions. So who has permission to read it, write to it, or execute files in it? Okay, read, write, execute. What I did here is I typed the same exact command, but I said sudo first. This is a big one. Please learn this command. In Linux, sudo means super user do. That means execute the following command as if I was the Lord. I'm super user. God, president, your mother, whoever is the supreme instructor that you would like to consider for the analogy. Okay. So sudo is super user do. Do the following command as if you were the super user. That's the best that I've seen. Make me a sandwich. Sudo, make me a sandwich. Very well. So kind of like what Simon says for Linux. Anyway, so let's check to see if the file was moved. I'm going to go to projects. I'm going to see, why is it not there? That's interesting. Codio's doing weird things. Very odd. All right. Well, either way, we're going to do it one more time since it somehow disappeared. So I'm going to make something called file.txt. I'm going to make sure that it's here. Okay, so we know how to make it. We know how to move it. Now I'm going to remove it. I'm going to remove it. And that's a whole nother, all it is rm. So if I remove file.txt, for this command, I don't need a destination because I'm just getting rid of it. And now it's gone. So that's how you make a file, move a file, go to different parts of the directories. Okay, so that's all we've learned to do so far. And again, like I said, don't freak out. It's completely okay. All I did was I want you to analogize this in your mind. It's as if it's your first day of a brand new language class. And I would bet money none of you speak Farsi. So I'm going to go with that example. And you came and you sit down and I taught you how to say, hello, my name is, can I have some tea? What's for dinner? And some other random statement. That's all that we've done here. Okay. I taught you like 4 different instructions for Linux and that's it. Right. So it might be. So that I don't want you to feel like you're freaking out. I literally just taught you 5 commands. That's it. You can always come back and look at it. And there's some more things that we're going to learn how to do here in a second. Here's some more commands. We already did pwd, which is print the current working directory. If I want to view or edit files, I can either use cat. So let's do, well, I got rid of file.txt. If I wanted to see everything that was in file.txt, I could have used the cat command. It would have just displayed the text file for me. You can also do nano or vim. Those are really, really, really basic text editors that are built into Linux. They're both god awful. I highly do not recommend ever using them, but just so you know, you can using the nano or vim command. You can do less or more. Like if I have a text file and it's like 382 pages. I can type less and more to like navigate through the amount of information. I can also do top or H top for real-time system information. I can use DF for show disk space usage, or DU to show disk usage of certain files or directories. These are all other things I can ask Linux for. So some command line tutorials in your Mac. If you guys are on a Mac, you can do this because a Mac will have a Linux terminal. I'm not, this system that I'm on right now is not a Mac. I have a Windows machine, which means I have a command prompt. This is my command prompt. Everyone see? So I have a command prompt because I am using Windows. If you're on your Mac, you have to do Launchpad and then go to the terminal. For Windows, I just have it bookmarked, but for Windows, all you have to do is go here. And then in search, you can type command. Before you even get past COM, it'll give you the system command prompt. You can just click it and it'll bring up your command prompt. There are also shortcuts for both of those. The command prompt here I would use, so we don't do ls. If I try to do ls here, ls is not recognized. The same version of ls for Windows is dir for directory. You see, it's pretty much the same. It tells me everything that's in the directory that I'm in, which is C user, right? It tells you which one of these are other directories. I have some files here. Let's say I want to go to my desktop for this. I would do cd. No, there. I do cd space desktop, and then I'm in user desktop. If I wanted to see what was there, I would do the dir command again. So it's very similar in terms of how form and function is, but the name of commands and the syntax of how you use them are going to be different. Okay. Then we have some Windows tools. So Windows tools. I already told you about the command prompt. CD works for both Linux and Windows. However, dir is the ls for Windows. There are different sets of security tools. So there's something called Windows Defender. Windows Defender is the built-in antivirus and anti-malware that Windows comes equipped with. Now, I have Norton on my computer. When I downloaded Norton, Norton takes over and disables parts of Windows Defender because you can't have both of them in charge of some things. They'll end up fighting and breaking your system. Okay. But without that, you do have some very basic antivirus and anti-malware stuff, and that comes through Windows Defender. BitLocker is also a Windows security tool. It gives you disk encryption. Yes, clearing the terminal is Control L. BitLocker gives you full disk encryption to protect your data in case someone steals your device or is able to exfiltrate your data like through malware or something. Okay. So you can use BitLocker. So whenever the data is at rest, it's encrypted. And so far that's encryption's been pretty secure. There's also, of course, Windows Updater. That's the thing that continually, reaches out to tell me I can't upgrade to Windows 11, even though I know I can. So for the latest security patches, any Microsoft pushes, things like that. For other things, there's something called PowerShell. All right. So when we were in our terminal, you can talk directly to the Linux machine on the command line interface. Okay. Just like I can talk directly to my Windows machine through the Windows command line interface. Does everyone follow so far? There are going to be some limits to what I can do even at the command line. So what they did was they expanded the capabilities and the amount of language you and your computer could have on the command line. In Windows, they expanded it through something called PowerShell. PowerShell, you can run a lot of PowerShell commands off the command prompt, but essentially on a Windows device, you can tell I do a lot of tech stuff because all this stuff is pinned to my toolbar. So PowerShell If you notice, it looks very, very similar to your command prompt, but you know it's different because it says PS for PowerShell. No, because Linux has its own PowerShell. It's called Bash. So it's a little bit different. PowerShell has like its own robust, self-contained, like full-on stuff. Bash is the programming language you use for Linux to get essentially the same stuff that PowerShell lets you do, but instead of, see here, PowerShell is a completely different like window. In the Linux terminal, we're going to be doing some Bash, but it's directly in the command line interface for Linux. It's not that there's one that's better for another. Okay, so PowerShell is available in Linux, but it's garbage for Linux. I don't care what anybody says. And it was not until recently, and by recently I'm old, so I mean in the last 10 years, to give access to it. So that's PowerShell. Wireshark, again, this is for Windows. This is for Windows. Wireshark is actually cross-platform, so I don't know why they put this as a Windows tool. But Wireshark is this. Okay, and what Wireshark does is it takes packet captures. Let's skip that version. It's going to take packet captures where you can look. Remember, we said packets were flying back and forth on the internet? If I catch any one of those packets, I can look at all of its parts and pieces. And if I'm on a network, I can capture all the packets that are going back and forth on the network. And I can use this to like look at them individually to say this packet went here, this packet went there. And that's what Wireshark does for you. Active Directory is something else. Active Directory is used primarily on devices that are run as Windows servers. It's really a key component of managing all your network services. You're not going to really be dealing with this on a home network. You have some cybersecurity protocols. You can use IPsec as a protocol. Windows Defender firewalls. There's a built-in firewall. Getting Wireshark. If you can't do packet captures. So unless you have several virtual machines or a network set up with multiple devices, it's not really super helpful. Can you guys see me? I know all of a sudden I got a flash that said my internet. It's been snowing down here, so hopefully my power will come back on very soon. So some real world examples. If you have a Windows server, you're going to see that in Windows environments. It's going to be used to manage networks. All of its services are going to work through Active Directory. There is something called PowerShell forensics. So security professionals, all this forensic evidence that we're talking about, you go and get it. You go and get a lot of that data, or you access a lot of those systems using PowerShell. You can actually configure the Windows firewall on your own devices. And the same thing with Windows Defender. Windows Defender is specifically for home users. If you have a professional or Active Directory, you're not going to have Windows Defender on it. So I want you to think you're a system administrator troubleshooting performance issues on a Windows computer. Which one of these tools would you use to view? This is a key word here, view information about running applications, processes. Yeah, you use Task Manager in Windows. Very good. All right. We're going to do, I already did this, so I'm not going to do a whole lot. If I pop this back open, this is, again, we're going to do the same things that we did before. Actually, is there a video? Yeah, so I don't have to do it. So just like we did all the things in the Linux terminal, you can do the same things in the Windows command line interface, right? But the commands are a little different. So we did the listing files and directories, type in the dir, still use CD to navigate to directories. mkdir, make directory, is still the command to make a new directory. So this is the same between Linux and Windows. However, if I'm going to create a simple file, I can't just touch example.txt. Windows requires that I use an application for that. The application that you're going to use in Windows is the first command that's going to go. This I do want to show you. All right, so here's my command line interface, okay? Say I want to make a file. I can't just say touch and give it the command to make a file. I have to call the program, and then the program, the application, is going to be the one that makes the file. right? Do you guys understand? So I'm going to say, hey, Notepad, go call on the program or the application Notepad and make me example.txt. Okay. Now you guys can't see this because it popped up on another screen. I got this message. It said, cannot find the example.txt file. Do you want to create a new file? The other thing that opened as soon as I typed it in is Notepad. Come here, you. Well, I can't pull the Notepad open until I answer this. So yes, I want to create a new file. Once that happens, you can see that Notepad also opened up. Now, the advantage of this is I can also start typing in Notepad. And then when I close this, I can save it, and that will be my example.txt, which is by far superior than any kind of Vim word editor through Linux. So definitely have some benefits one way or the other. Sure, save it. Why not? Now, instead of copy file, so instead of MV being for move and RM being for remove, we have, you can copy it or move it to another file. And you would use the commands of copy and move for that. Yuck, David, nano, bleh, I've used it before. Terrible. I can also delete a file. In Linux, it was RM for remove. In Windows, it's DEL for delete. So I could go back to the same place I was, and I could say, hey, go ahead and delete that example.txt. And if I went dir, you could see it is not here anymore. Okay. And here's an entire video of it, so feel free. Here's some more file operations. So creating a text, again, Notepad, name the new text. You can also use the command type to see what, okay. If I want to open the file in Notepad, that's one thing. Remember I told you in Linux, if I wanted to see what was in the file, I would type cat, and then it would go get the data from the text file and show it to me in the terminal. The same equivalent to that is type for Windows. I would look, I'm going to give you the honest truth. Should you know all of these? Yes. Is the most effective way to learn them to memorize them? Absolutely not. You need to just play with it. You need to go spend some time, make files, try to manipulate files, move them from folder to folder. And we're going to do a little bit of more of that today. But the best way to actually learn these things is to use them. Just memorizing a list of commands isn't going to do you any good, because you also need to know when to use what. Okay, so this is much more of a hands-on doing sort of activity. And then, yeah, because it's super easy for me to be like, oh, how do I remove a file in Windows? Google exists, guys. And I promise you, Google AI will very quickly give you the command that you seek and give you a nice little example of how to do it. So there's a lot of opportunity for practice here. All right. There's more of these where you can like watch the video of what they're instructing. You can use system info. You can use task list. ipconfig is a big one. So I'll just do this and you can see all my IP information. The command of ipconfig literally will run down all of your IP configurations for your network. So for me, I have my Ethernet adapter. I'm going to trust that none of you are going to hack my system from where you are, but I'm giving you all of the information you need to crack it. Good luck. May the odds be ever in your favor. But essentially my IPv4 address, my subnet masks, and everything else, all of my my data for my Ethernet adapters, wireless LAN, all that stuff. Wouldn't do any good. I'm on a virtual machine anyway. So that's for ipconfig. Check disk is essentially check your disk for errors. What class C and no good IP6. So it's the same for PowerShell. This is more for advanced stuff. So again, like I said, Windows has the Windows terminal or yeah, command prompt. Linux has the Linux terminal. Windows also has PowerShell. Linux has bash, but bash doesn't have its own terminal. Bash you can do directly from the Linux command line interface, okay? I actually teach Python, so yes to the Python question. So in conclusion, I want you guys to pay attention to these exercises. I would highly recommend after we conclude here today, you run through these exercises. Your entire lab, your next class is going to be command line interface, okay? Why would I want to ping Google? That ping 8888? Anyway, this entire, all the command line interface stuff, you're going to do it all in the lab. Okay, now practice on your own too, especially if you're really lost and confused. I promise practice a little bit. It'll feel a lot less daunting to you. How are we all doing? Before we do permissions, I want to give us a pause here. I'm going to let you guys take a break. I'm going to let you breathe, maybe catch a drink. Yes, we're going to get into permissions, chmod, sudo, all kinds of good stuff. All right. It's fine. Everything is okay. It is 4:44. Let me check. Yeah, we got plenty. I'm going to give you a whole 15 minutes. You guys will be fine. We'll finish in plenty of time. I'm going to give you a whole 15 minutes. Come back at 5 o'clock. And we're going to do the rest. Okay? All right. Made a somewhat executive decision. May Lindsay and Lakidra forgive me for it. I'm going to sacrifice Kahoot time because I want to back it up a little bit. I want you guys to listen to me because I know a lot of you are feeling confused and overwhelmed out of the 700 and change that we have. For the 300 of you that know how to use command line and all that good stuff, please disregard. For the rest of us, okay? Take a deep breath. If you've ever seen the movie The Matrix, you've all been red-pilled. Okay, so we've dropped through the rabbit hole. And if you're feeling overwhelmed, that's okay. I want you to think of it like this. Your whole life, since childhood, and you learned language, you've existed in a world where you could communicate, right? Every one of you can, at least to a certain extent, interact with the rest of us. You can hear me in English, or if not, the ASL interpreter. Either way, you can understand the words that I'm speaking and or typing, right? You live in a world where you understand the communication that I'm giving you. This is as if I took your hand, all of you, and walked you into a room with 10 new people, and none of them speak the language that you speak. But they also don't speak the same language as each other. Does everyone understand? Every device that you use, from your phone to your computer to your tablet to whatever electronic device that you have, has some form of operating system. Does everyone understand? That operating system at its core is the language that that system needs to operate. Okay? Now, your phone doesn't speak the same language as your computer. It has a different operating system. Just like when you're on your phone, you use your thumb to scroll around, right? Touch screen. Windows devices can have a touch screen, but we use our mouse and we double click on things. That's the language that you're accustomed to interacting with. I'm getting rid of all of that. You have to use the language of the device. Okay? If you are on a Windows machine, okay, that language operates on the command line. Command line interface is you speaking directly the language of the computer based on its operating system. Now, just like human beings can speak multiple languages, different operating systems can incorporate different programming languages. Python can be spoken by any device. It is operating system agnostic. PowerShell was originally designed for Windows, but now it has a version for Linux. The Bash language, scripting language, only works for Linux. So with the example that I gave you, I know you're feeling overwhelmed. It's as if you walked in the door and I taught you those 5 phrases in French, Chinese, Arabic, Farsi, and Kurdish, all at the same time today in 10 minutes. Of course you're feeling overwhelmed. I'm introducing you to like 4 new languages. Okay? You got this. Do not be overwhelmed by it. It's just a basic understanding of the organization is really all you need right now. Understand that Windows has a command prompt and that PowerShell is used for scripting in Windows. Okay. Linux uses the command line interface, and Bash is the scripting language that we use for Linux, right? All the other stuff is the specifics of the languages. You can get to that later. All right. Did that clear up a little bit for you guys? Maybe, I hope. A little bit better? Okay, breathe in, breathe out. We're good. Now, for some people that had some problems getting to the terminals and command line interface, if you are sitting on a Mac, I don't know what devices you have. There's like 800 of you, okay? If you're on a Chromebook, your operating system is also different because that's a Google device. You may not have a command line interface that's Windows or Linux because Chromebook doesn't have either of those operating systems. You guys understand? So if you're on a Windows device, you should be able to go to your Windows and type command, and a command prompt should open up. This is on your actual computer, so don't do any crazy stuff here that might damage your system. All right. If you are on a Macintosh, there is a different series of things that you have to do. And over here, let's see, where is it? Linux terminal. How to launch the command line on your machine will tell you. In your Mac, you can do either click the launch pad, then click terminal, or in Finder, open applications, utilities, and double click the terminal. I can't show you this because I'm not on a Mac. What I can show you though is inside of Codio, you can go to tools and go to terminal. And when you do that, a terminal will open for you here inside of Codio. Does everyone see that? Can you do it on your iPad? You have to have an app to do it on an iPad. It does not have a native command line interface. An iPad is a completely different operating system. This is your sandbox. Yes, inside of Codio, it would be considered a sandbox. If you're on Mac and you're running a VM with Windows, you could do both, but you would have to be inside the Windows VM to open the command prompt there. And on the Mac, you would have to be outside the VM. I know you cannot search the terminal in your search bar for Mac, can you? I don't know. I don't do Mac. So that's some basics I wanted to cover here. Now we're going to talk about permissions, okay? So here's the deal with permissions. Permissions are just like passwords for things, okay? But instead of a password, I'm going to give you permission to access or to alter or to use certain things, all right? So for example, in my house, I have twin 3.5-year-old children. I have 2 of them, okay? I also have a 16-year-old son that's taller than me. For the stuff I don't want the twins to reach, I either lock it up or put it out of their reach so they cannot access it, right? That's all permissions are. Who has access to see, use, or alter certain directories or files, okay? So we're on, yeah, because we covered the tutorials. This is literally how to launch the command line on your machine. So we're on, what happened here? We covered this already. Overview of the command prompt. Why did this not go where I wanted it to go? There we go. So we're on number 11, setting permissions in Linux, okay? Covered the help option. So permissions are this, in Linux, so we're talking about Linux again, okay? Specifically, we've gone back into our operating system of Linux, so we're only speaking the language that Linux speaks. This does not necessarily pertain to how Windows operates, okay? Can you guys see my screen? Okay, so most people can see the screen. please troubleshoot. Okay. So for Linux, files and directories have permissions. So it's not just the file itself, it's not just the programs itself, but the whole directory can also have a permission. The permissions are divided up into 3 categories. The owner, which is usually the creator, so whatever account or user created the file or directory. The second is the group. So each user is assigned to a group. And then what access does that group have? And then there's everybody else. Okay. So again, user, group, everybody else. Okay. So those are the 3 categories or 3 parts of the permissions in Linux. Now, there are also 3 levels of permission. We have read, which just lets you look at or view the content of a file or a list of a directory. That's it. You can see it. The next one is write, which means I can modify the file. I can write to the file. I can create files in a directory. Okay, so I can edit. Then we have execute. To execute a file, there's a difference. So if I download a program onto my computer, I can do stuff to the files, right? Or I can just download it and look at the file. But executing it means letting it run. So it's like I have a car in my garage. I want you to follow me on this analogy. I have a car in my garage. If you can get access to the car, you might be able to pop the hood and do stuff to the engine. Or if you don't have access to the car, you can still look inside the car, like look inside the windows, right? But you have to have the key to turn the car on and drive away. That's going to be your read, write, execute. Okay, so executing a file is a little different. So, and they're represented by R, W, and X. To set permissions, I need the command chmod. Okay, chmod. Then I would include what permissions for what file and directory, right? So let's do this. So I have project. Let's go to that subdirectory. So I'm inside a project. Let's make a file. All right, so you see, I went to projects. I made a file called new.txt. So let's see, first of all, I want to see what permissions new.txt already has. Okay, I can do this with the ls command by adding an option tac l. Tac is the little dash. Okay, so tac l. When I do this, it gives me all the permissions and all the additional details of each directory and file in addition to listing everything in it. Does everyone see that? Here's how we would read these. There's a subdirectory called backup, and I know it's a directory because the first letter here is a D. Where you see a D at the beginning of permissions, that indicates that the thing in question is a directory. Okay, so this is a directory. RWX is read, write, and execute permission. The first category is for the creator, the user. The second set is going to be for the people in the group who only have read and execute. They cannot write. And then the final one is for everybody else. In the case of this, the group and everybody else have the same permissions. That's how you would read them. The first set of 3 is for the user, so the owner of the file. The second set is for the group that is a part of. And then the third one is everyone else. And that's how you read the permissions. And they're always RWX. And where something is missing, you will see a dash, right? And there's a lot of places that you can go. Here is the best. No, that's not what I want. I have a website here for you. It's Red Hat Linux file permissions. It gives you a really nice rundown. So if you want to read more about these, go here. It runs it down really nicely, gives you all the information. It's pretty good. So you would use the command change. Chmod is basically to set permissions. So now that I know what the current permissions are, I can change the permissions. Now there's two ways of doing this. The command structure is either I can change it for each individual organization. So U plus RW means I want to add for the creator, read and write access to the following file. That's how I would read that. That's one way of doing it. The other way of doing it is a numeric value. Read is 4, write is 2, and well, there's 7, 6, 4, 2. Go to the website. There's a calculation for how you add them together. So basically, God mode would be chmod 777. Just so you know that you add them together so that if it's read, it's 4, if it's write, it's 2, if it's execute, it's 1. So when I add all of those together, the highest number is 7. If I get a 5, I know it has to be a 4 plus 1. So that means you have read and execute only and no write. Does everyone understand? So like there's a numeric representation for this as well. So just as an example, I will do change for new.txt, but I want it to be, watch it not let me. Okay, so now I'm going to do the same command. And you'll see this is what it was, which is only read, write, and read. So this is for the owner, this is for the people in the group, and this is for everybody else. 777s means the owner, the user, and the group now have read, write, and execute. It's green now because before I didn't have it's showing what changed, basically. Right? Now, if I want to change it the other way, so I'm going to do the same thing, but only I'm going to use the other commands. So I want to change it to where everybody else, that's O, only has read permission. Let's see. I probably should have done this the other way. And then I'm going to check it. Yeah. I should have done it the other way. Yeah, I'm not as used to this format. I use the numeric format much more. So we'll try that again. And I want 741. New.txt. All right. So what 741 does, so remember, this is the user or the owner, this is the group, and this is everybody else. Okay. So here you can see user or owner has read, write, execute. For the group, I gave it 4, which means you can only read. That's it. And for everybody else, they can only execute. Everybody else meaning everybody that's not fitting into the category of the person that created the file or the group that the file is assigned to. That's who everybody else is. Okay. In Linux, all users are organized into groups, right? It would be like me saying your first name and your family name, right? So let's say there's me, my husband, and we have 3 kids in this house. So we're all of the group Crow. Okay. Each of us has a first name. If I cook a meal or I have a recipe, that's mine. I wrote it. Right. So I would only have access to like change the actual recipe. But say everybody in my group can read the recipe. So if you come into my house, even as an invited guest, you're not part of my group, but you have access to my home. You have access to my network. So you can have within one network, you can have multiple groups as well. So for example, I have an accounting group. I'll have a system admin group. I'll have a sales group. I'll have a guest group. Okay. So I have all these different groups and each user is assigned to at least one group. You can be a member of multiple groups. Did that answer your question about the groups? All right. So this is how we change permissions. So speaking of users, okay, speaking of users, let's say I can actually add usernames. I can alter user passwords. I can change the groups. If I want to know who I am, I can just say ID. Just type ID. If I type ID, you'll see I have a user ID of 1000 for Codio. This is my GID is my group ID is also Codio. And I'm a member of the group's Codio. Somebody building VMs was lazy. So this is just like the generic standards. It's okay. So now if I wanted to change my ID, so my username is Codio. Okay. So I could also do it by name. When you ID it, IDs yourself, right? So let's create a new user just to say that we did. Okay. So we're going to do user add command. Sudo user add and pick whatever you want. I'm going to do Crow. Okay. Now, sudo password Crow. Oh, because I've fat fingered it and I can't type. Password. Okay, when you type the password command, Linux will prompt you to enter a password. Okay. I'm going to enter the password. If you notice, you could hear my typing, but nothing showed. It still went in. Retype new password. Watch the cursor. It's not going to move. So that's the password for that username. Okay. Now I've set the password. You have to do this with sudo because it has to be super user do. Now for user modifications, this is like chmod, but instead I'm going to alter the user's categories. Okay. So I want to change the user's like group or whatever the case may be. But first of all, I want to know what group it's in. So now ID that new user Crow. And it's going to tell me Crow has the user ID of 1001, the group ID of 1001, and is in groups 1001. Well, I don't want it to be 1001. I want Crow to be the same as me. Okay, I want Crow to be the same as me. So I'm going to change it. Okay, let's change it. Let's do sudo user mod. I want to change the group. 1001 Pro. But I actually want it to be 1000. Delete. All right. Now let's ID Pro again. Nope. Yep. So what happens is when you change the group, in this case, I didn't change it. I added it to group. So now Crow is a member of the group 1001, but also the group 1000, which is the Codio group. Does everyone see that? So you can change the user's groups and specifications, just like I can change the permissions on a file. Guys, I apologize. I know you can't see me very well. I live in Georgia. The snowstorm knocked my power out. I'm actually on backup power, but my backup power is not good enough to run my my lights for streaming. So my bad if I'm starting to be Emperor Palpatine again. I was hoping my power would come back on, but it has not. Add group. AG is add group. It's okay. That's why I have backup power systems. You suspect I'm an AI. I wish this job would be easier. All right, so I can also delete a username. So since I made the Crow username, I can also sudo user delete. Oh, it got mad. That's fine. So all of these is basically adding a group, adding a user, modifying a user, changing passwords, things of that nature, right? So I'm not going to get super into it. If I do want to see, this one's going to be key for cybersecurity. Etsy password. So remember, cat was display, right? So I want to see, I wonder if it will let me. It should not. If they've done this correctly, it would not show me this. Oh, you are terrible. All right. So what happens is when you type this command, when you type the command in, which is actually, let me do this so you can see it cleanly. Cat Etsy password. Okay. Linux by default has a file called password in a directory that everyone refers to as Etsy. Okay. So it's etc., but Etsy. If you have access to this, what it does is it gives you the user name, all kinds of data, including passwords, directories, groups, all that stuff. This is basically the master list of where things lives. So you really don't want to let people have access to this, but it's going to display all your users and a whole lot of additional information that if you ever decide to take incident handling or any kind of hacking will be of use to you. So what are some key considerations when setting permissions? Well, you want write permissions, read permissions, execute permissions. Those are the important ones. Oh, and the numeric representation, just so you know, what 7 represents, what 4 represents, what 1 represents. So this is some more managing permissions practice. So you guys can run through this if you like. I'm going to blow through it really quickly just so you can see me do it. So first I'm going to okay, so I'm still in project. That's fine. I'm going to make a directory called project inside of project. So that's not right. Let's go back up one. Since project's already here, I'm not going to make it. Then it tells me to go into that subdirectory. So I'm going to go ahead and cd project. So you can see me go into project. Okay. Then it says touch data.txt. So I'm going to create a file called data.txt. Make sure it's there. It is there. Then I'm going to modify user to only be able to read and write to the data. So let's see. First of all, what is the permissions now? All right, so it's already read and write. So that's not going to do me any good. I'm going to change it to read, write, and execute, just so you can see a change. So change mod. Let's do u plus rw. Now, rwx. Now, u plus rwx can always be replaced by 7. Okay, 7. No, 777 would change user group and everybody else, because that 7's going to give them each all 3, right? And then to the file data.txt. Yeah. So I have to specify all of them. So let's see. So we'll do 7, 6, and 4. And 764, if I've calculated right, which I should have, 764 will be read, write, execute for user, read, write for group, and only read for everybody else. So now ls tac l to check. You can see it's, as I said, read, write, execute for user. For the group, it's read and write, and for everybody else, it's only read. Okay. So, and there's some more you could do. You could create script, chmod, adding things, checking, so on and so forth. I would recommend you doing this practice. Okay. No. So you have to give it, you can't do 7 tac. If you don't want them to have anything, you could do 0, I think. You guys are making me like take it way old back. Let me do it again. So let's say I don't want them to have any. I think 0. Yeah. There's no, when I did that, it was incorrect. which is why I went back and fixed it. You can't do the TAC, but you can do the 0. 0 means you get nothing. Okay. All right. And again, don't freak out. You can come back and practice all the changing permissions if you like. So here's another one where it just continues. We can make a directory for my project. We're going to change the directory into my project. We're going to make 3 directories. We're going to create 3 files, and then we're going to move stuff around. All right. So I want everyone to look. I'm going to walk it through step by step. Okay. So first of all, I'm in workspace. I'm going to create a directory called my project. So mkdir, my project. ls to check. Everyone can clearly see my project has now been created in addition to project, which was already there. Okay. Now I'm going to go into that subfolder, cd, my project. I'm now in that subfolder, which if I ls shouldn't have anything in it, and it doesn't. Okay. Now I'm going to make directory, but there's 3 of them. Let's check out those 3 directories. And if you didn't know what I just did, I literally just did copy pasta. Copy, you can do multiples at once. mkdir, I don't have to do 3 different ones. I can do all 3 at once, separated by spaces. Now I can clearly see 3 directories. Now, I am going to make a file called file1.py. For those of you that don't know, that's a Python file. .py is the extension for Python files. You can open them in text editors as well. Okay. So I'm going to do this. Oops. That with me because I wasn't in the right place. Here we go. So first, command to create the file is touch. And I'm going to tell it where it's going to go. So first of all, it's going to go in module 1. And then I want it to be named file1.py. Now, if I don't want to give a destination, it will default to whatever directory I'm in. So if I didn't tell it to put it in module 1, it would by default make that file in my project. Yes, the directory is the equivalent for folders, essentially. Technically, there's a difference, but not really. Okay. So everyone's with me. I'm going to create a file inside the subdirectory module 1, and I'm calling it file1.py. That's how you would read that. I'm going to hit return. I'm going to check. Well, I can't check because I'm not in module 1. So I'm going to go to module 1. And then I'm going to check, and there's file1.py. Does everyone see? All right, so I'm going to do the same thing, but I want file2 in module 2. And I'm going to do the same thing, and I want file3 in module 3. Okay, now inside of my project, I have module 1, module 2, module 3. Each one of them have file 1, file 2, file 3 inside of them respectively. Okay. We can verify with ls. So let's do, I don't even have to leave my directory. I can say list me everything inside of module 2. File2.py. Excellent. How about module 3? Very good. And module 1? There you go. Py is just a file extension. It's like saying .doc or .text or .jpg or .pdf. It's just a file extension. It's how the computer will translate the 1s and 0s to put together that file. That's all that means. Okay, it's the format. Now, I want to move. This is what this is saying. Let's read it together. I want you to move file 1, which is located in module 1, and I want it to go into module 2. Does everyone see that? That's what I'm instructing the system to do. So once I do that, when I look at what's inside of module 2, I see both file 1 and file 2. And when I look at what's in module 1, because this is the move command, not a copy command, it should be empty, and it is. And it is. Okay. Now, if I want to just remove module 3, and then I say, hey, go to and list for me what's in, actually, you can see I only have module 1 and module 2 because I removed the entire directory of module 3, which means the files that were in module 3 are also gone because I just deleted everything. So that's just some basic navigation and playing in the terminal. Another case study, we're going to make project, go to the project. We're going to make multiple directories here. You're going to make multiple files in the different directories. And then you're going to check to make sure those files were created. And it wants you to make another directory called backup and then move all your docs to backup. So I'm not going to actually go through every aspect of this because this is just practice. Okay. So you can do this in your terminal. You can get some practice and check it. And line by line, all of these things should work. Can you bring back a file that was removed? No. Once it's deleted, in order to do it would require a lot more information than what we have right now. Yes, technically there would be a way to recover it, but not this easily. Is there a copy command? Yes. But so you can use CP for copy. The problem is you can only use it for files specifically and not whole directories. Did that kind of answer the question? So yes, you could. You can copy it and put it somewhere else. Okay. Any questions right now? Any questions? There are ways to copy directories, but they're not that straightforward in Linux. Is there some of Git control? So many. You want to start from the beginning, the whole lesson. How don't get the workspace? Because, okay, so if you're in workspace, you have to CD. So see how mine is my project, right? See how now it says workspace? When I'm in workspace, I have to make sure that I have a directory called my project. From here, I can then do CD. If you just do a capital M and tab, it should open up with my project. When you do that, you should have workspace / my project. Okay. I got an error when using you shouldn't be using pi command. It's an extension. So when you're using pi, it's .py, main.py, readme.txt, no spaces. It's literally just a file name. It's tedious if you're creating users and groups. Yes, it is, but on a large scale, you can do it by batch and you can also do it by file. The terminal that you're seeing here is running through a VM. Yes, it's a web hosted VM. Do the command. I don't understand the question, Ronald. All right. So if I were you to solidify this lesson, I would definitely go through and try to do each of these commands one at a time. Okay. And literally it is just like learning a whole new language. You're not going to get there. It's not going to really hit full understanding until you practice, until you use the commands, until you practice with the commands over and over and over again. Okay. So now, as if that wasn't sufficient, remember that was just command line interface. Now we're going to go into scripting and bash. Take a deep breath. Now I'm about to teach you math in a foreign language. Okay. Here we go. So bash is a programming language it's a scripting programming language that you can use directly in your Linux terminal. And essentially what this is the very basics of coding. This is line by line coding. So echo means display whatever I'm going to give you. It must go in quotes. We're going to do hello world, which is the generic first line of code for every language. Okay. Except for I can't spell, or at least not and talk at the same time. Okay, really? Really, Hecklo? I should have done Henlo, just for fun. So echo, don't forget the first quote. I swear I code better than this. So when you do that, you're commanding through bash language to say, hey, write out for me the following string, and string is anything that's script. So that'll show you hello world. That's a very basic line of code. Here, I'll even show you. So this is bash. This is Python. The same command in Python looks different because it's print instead of echo. Okay, but when you do that, it gives you hello world. Your command prompt will do the same thing. It also takes print. Okay, for hello world. No, I got to go to Python for this. So I can actually run Python on my command prompt by going to Python, and then I can use the print command for hello world. Okay, so echo is literally just the command for print, which is display the following information. That's all it is. Now, by itself, it might seem pointless because you're just typing hello world. So I don't understand why it makes sense. But when you combine it with other code, it makes sense. For example, first, we're going to create some variables. Okay. I'm going to take a variable, it's called name, and I'm going to assign it the value of John. Okay. Once I've done that, I'm also going to create a variable named age. I'm going to assign it the value. That's what the equal sign means in coding, of 25, which is a number. Okay. So I'm going to do that as well. Now echo is going to make more sense because I'm going to tell the computer, hey, write out the following. My name is. But now I'm not going to put name. I'm going to insert a variable. And I'm going to preface the variable with the cash sign. And so it's going to say, my name is name. And I am age years old. Does everyone see that? When I do this, the computer is going to return for me, my name is John and I'm 25 years old. Okay. So this is essentially how coding works. All you have to do is watch and follow along right now. This is like your first exposure to the information. Now I can also just call back those variables anytime I want using the cash sign. Command not found. So it doesn't like callbacks. That's fine. Other things that you can do in bash. Other things you can do with bash is for loops. So when we say automate, okay, listen to me. Let's say I have a text file with 500 names in it. And I want to assign each of those names a user ID or a numerical, like 1, 2, 3, 4, 5, all the way through. And there's like thousands and thousands of them in this file. I don't want to do that manually. Can you imagine how much time that would take? I can set up a script to do it automatically. Okay, and this is how you would do it. I would say for I in, this is a loop, for I in. Now in this case, I'm only going to use 1 through 5 instead of 1 through like 5,000 or 500,000. But to the computer, it makes no difference. I could do this 1 through 500,000. Okay. Or I could do for I in lines on names in a text file. Okay. So this is just for I is a numeric representation for each one. Okay. So in order. So the first time I is 1, the second time I is integer. Yes. Essentially in mathematical formulation. But I is the first one. So it's 1 in the first loop, 2 in the second loop, 3 in this. So every time it goes, it changes to the next one. Okay. So for I in the range 1 through 5, and when I hit return here, it gives me a prompt because the for loop requires multiple lines of input, and Bash knows this. So the for loop is now executing. I want you to do the following. I want you to echo, which means print for me. Okay. Iteration. So the word iteration, and then whatever I is for that loop. Does everyone see that? Whatever I is for that loop. When I hit return, I have to complete my loop, and it's going to go iteration 1, then go up, iteration 2, and then go up, iteration 3, and then go up, iteration 4, and then go up, iteration 5, and then go up. Does everyone understand? This is how Bash can automate things for you. Guys, we do the exact same thing in Python. I know this is not a Python lesson, but I want to bring this up just so you can see, okay? Did you guys see how I did the for loop here? For I in brackets 1.5, do echo iteration, cache I, done. Python can do the exact same thing, but it's a different language. Okay. All right. So this is essentially going to give me the exact same thing. Nope. Why are you mad? For I in range 1 to 6, print iteration I. Type error. Line 1. What just happened here? All right, let's just do I in range 6. I know why. My Python language skills are completely obliterating. Do this again. All right. This is why. Because I'm trying to index something that doesn't exist. All right. Go back. Go back. Sometimes Python is difficult. There. Same thing. Okay. Sorry. It works better when you don't fat finger, and it's harder for me while I'm talking to you, but it's the same code. Okay. So there's no difference for I in range 1, 6. Now the difference is, notice I had to start at 1 and stop at 6 because Python starts exclusive or inclusive and ends exclusive. So it stops before 6. So you can see the terminology looks different because for I in curly brackets 1.5, this is for I in range parentheses 1, 6. But the end result is the same. So it's literally just a different language, but it's doing the same thing. It stops when it gets to 6, but when it gets to 6, it stopped, so nothing happens after. If I said, what is I now? It stops right there. I is now 5 because it never went to 6 because it stops before it gets there. All it's doing is printing for every line. See, first I showed you how to make a variable. then we're iterating. If you really want to know what it can actually do, right now it's just printing at each. What I could tell it to do is I could tell it to create a file with a file name, enter data, make calculations, and go to the next file instead of just printing a name on each line. This is your learning step by step by step by step how automation works. Yeah, good. And this for loop that we just showed you, this is the very basic for loop, which is what automation needs in any scripting language. Python always starts at 0. In this case, it would also, but I specified 1 to 5, right? I specified 1 to 5. All right, so I can also do if conditions, okay? This is a different kind of coding. So instead of automating to do one thing after another, I can say only do something if, and I do that with an if conditional. In this case, I'm going to say if, and I would put this in brackets, the age, and this is a variable that we already entered. What was age? Age, I believe, was 25. If age is under or over 18, and you just have to know for each programming languages what these instructions mean, what the keywords are, what all that stuff is. But if the age is, in this case, over 18, then I want you to print or echo, you are an adult. Okay. Else, I want you to print or echo, you are a minor. Okay. And then when I'm done, I'll do fee. So because age was already over 18, then it's going to tell me you are an adult. Now, where this becomes useful is instead of a variable, if I take user input. So now I have conditions. So if the user inputs their age as this, you give this response or give this access. If it's not, then so this is how we manipulate and get the computer to do stuff for us. Okay. No, if you specify 1 to 5, Python includes the first number and excludes the last. So it would be 1, 2, 3, and 4. All right. So here's an example script. Let's just read through it to see what's going on. First, I'm telling it to print, welcome to the personalized greeting script. And then it's going to give me a whole line, right? So an underline, essentially. Okay. Just because I can think of more reasons to being like, no, 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 no minors than adults, probably because I'm old. So when you use the command read is the bash keyword that will prompt you for user input. So I will read TAC-P and it will give it the instruction of enter your name, and then it'll give you a prompt where the user will have to type in their name. And the same thing for enter your age. Now, name here means assign whatever they give to the variable name. And then age is saying the same thing, but assign whatever they give here to the variable age. And then you'll have your if condition. So this basically, if we ran this entire script, what would happen is the computer would ask me my name and I would give it. The computer would ask me my age and I would give it. And following that, the computer would say, hello, your name, you are an adult, because I am older than 18. Does everyone understand? In this program, today is like the last day. Today in the lab is the last day you're going to deal with Bash. And I don't think we deal with Python at all. This is the basics. If you want to go further in this field, you're going to have to know the crap out of Bash, and you're probably going to have to know the crap out of Python too, depending on which way you want to go, Suit or Gremlin, and in which subcategory you decide to become proficient. So that's a hard question. Okay. I know a multitude of computer languages because I started off in computer science and software engineering. So I am a bad example. If you want to be a suit, just the basics of Linux and understanding what Bash is will be sufficient. For the Sec Plus, you really only need the very basic Linux commands we covered in the beginning. So change user, so chmod, sudo, so knowing how the permissions work, how to traverse files and navigate, that's it, maximum. That's the most you're going to need for Sec Plus. And a lot of that might not even come up anyway. Some of it will, but for the most part, no. Are the suits the ones away from the computer? The suits are the ones that talk to the gremlins and then go translate for the C-suite. Okay, so for the executives and the normal people. I hope that answered your question. All right, so practice this. And then that's it. So essentially we covered a lot, guys. Like I said, don't freak out. I literally red pilled you guys today. So I know it was a lot. Please go over the material. Please practice. Don't forget you're going to do all your command line interfaces as a lab, so you don't have to worry about any of that. You're going to go over all of that with your TAs. Okay. So key things for networking concepts. Don't forget that first part that we covered is going to be the majority of what you see on Sec Plus. I'm going to say that again. The part right up until the command line interface is all the raw data and information that you need, and you will see every bit of it on Sec Plus. The OSI model will probably be on like 7 different questions in some form or fashion. Okay, so really, 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 really focus on the actual information from the very beginning of today. Okay, which is basic networking hardware, switches and routers. I would go to YouTube if I were you, and I'd look at the OSI model. I would go to YouTube if I were you, and I would see how do packets fly across the internet. Definitely, you're going to want to have a firm grasp of that for Sec Plus and anything else you want to do in this career field. We introduced networking tools. Know what these things do. That'll help you on Sec Plus big time. Know what TCP dump is, netstat, netcat, wireshark, all of those things. Just know Windows Defender, what Windows BitLocker is. Just know the words and what they mean. Windows BitLocker being the encryption for the data on an OS device. Windows Defender is the preset or pre-installed Windows firewall and malware analyzer that comes on default for Windows user devices. Like, know what these things are. Know what Active Directory is used for. You need to know just at least the definitions. Okay, those are really, really, really a big deal. You're going to see them on multiple questions on Sec Plus. For Linux fundamentals, we did the basic terminal commands, directory management, how to manipulate the files in the directories. We learned about permissions, how to do user management, so change the user and the groups and assignments. We talked about the Windows interface. I showed you PowerShell, but we really didn't go through the basics. There was a little video that you could watch. Please go back to those. I'm going to say, please go back to those. Each of those had a little short video that shows you how like PowerShell is different than Windows, than the Linux, and so on and so forth. Okay. And then we did very basic scripting. Okay. So just so you guys know, command line interface is when you're talking to the command prompt in Windows or Linux in the command, Linux. Bash and PowerShell are the scripting. Scripting is like baby programming, okay, baby coding. The difference between scripting language, so there's 2 categories, scripting languages and compiled languages. Compiled languages are like Java, like C++, like pretty much anything other than Python, okay? And the difference between the two is if you saw when I did scripting, every line I hit enter after, and I could just keep typing. Scripting is usually an interpreted language, which means the system is interpreting every line of code as you're doing it. A compiled language means I have to write all the code, send it through something called a compiler, and then the machine code comes out and the whole thing is executed at once. I can't do it line by line. It's like the difference between cooking on a stove and baking. If I'm cooking noodles and pasta on a stove, I can add ingredients, I can toss in salt, I'm doing it piece by piece. When I bake a cake, I gotta put the whole thing, and then once it goes into the oven, I can't change the salt content. I can't change the ingredients. That's what a compiled programming language is like, okay? Just so you guys understand. So when they say scripting, they're talking about writing in a programming language that is interpreted or line by line. Is there a job where you do the attacking? Yeah, it's called pen testing. So, okay. I think that's everything. We have like 2 minutes, and I already said we wouldn't have time for Kahoot. I'm gonna leave it up to you guys to cover the Kahoot at the next lesson. So I hope that's been good.